series. In the previous video we talked about arc length. I gave you a definition of what arc length was. We talked about a sector and what that was. I gave you a diagram showing you what a sector is. I've drawn one just here in yellow. I showed you what the arc length would have been for this sector. So this is what we call the arc length, defined as L. We've got the angle in here, theta. We also have these two lengths over here, which are the radii. Each one is the radius of our circle. So if I draw the circle that this has come from down here, let's say that's our circle. So we have taken this sector from here, okay, and this represents our arc length. So that's what that little sector over here, that's where it's come from. Now, if I want to look at arc length, I want to talk a little bit about how theta, or this angle between the two radii and the arc length, how they correspond to each other. Now, if we look back at our circle, I'm going to say that this sector over here, this is a quarter of my circle. Now, if that sector is a quarter of my circle, then this angle in here, this is going to be a quarter of my revolution. Now, a revolution, or the angle within our circle, is 360 degrees. Now, if I look back at my circumference over here, if I look at this circumference over here, if this angle is a quarter of my revolution, so a quarter of 360 degrees, this arc length over here has got to be a quarter of my circumference as well. So we can say that the arc length L is proportional to theta. So this means if I take a fraction of the angle within my circle, so if I take a fraction of 360 degrees, I will be essentially reducing that angle of 360 degrees in the same proportion as I would my arc length. So I would be also taking a quarter of my circumference C. So these two will reduce, if I'm reducing my angle within my circle, so I'm also reducing the circumference by the same portion. So what that means is if I say my theta now equals 90 degrees, I can figure out what fraction theta is of 360 by writing it 90 over 360 degrees. I can now reduce my entire circumference by that fraction as well. So the way we can write that is we can say 90 over 360 multiplied by our circumference, and that will give us our arc length. And you can really do this for any angle theta. So if I take you to a new slide, I'll show you what I mean by that. So in the current slide we had 90 over 360 multiplied by the circumference equals our arc length. If I have another sector, let's make one that's a little smaller, and I say that this is 60 degrees. So now I know that we've reduced the arc length by the same fraction that we've reduced our angle within our circle. So I can say in this case 60 over 360, so I can make the angle within my arc length a fraction of my entire angle of my circle, and knowing that the arc length will reduce by the same fraction, I can simply multiply this by the circumference, and that will give me my arc length. So if I was to write that as a formula, the way it would be written is arc length L would be theta over 360 times my circumference. Now, if I know that my circumference is over here, from the previous video, we figured out that circumference can be written 2 pi r. Now, this is why I gave you this formula previously, because now we're going to change our c and make it 2 pi r. So what we would get is we would get arc length L is theta over 360 times 2 pi r. And the reason why is because we're not always given the circumference of our circle. A lot of the times we're given the sector, and within the sector we have these two lengths for radius. So this is where when we're talking about arc length, we need to talk about that portion with regards to theta, with regards to radius, and with regards to this. So that's where this formula comes in. So I can do a worked example for you. I just want to reduce this screen down a little bit. I'm going to give you a worked example. So let's say we have a circle over here. We've got radius here is 3 centimeters. We have an angle within this sector here being 50 degrees. I want to work out what my arc length is. So I would simply use the formula over here, substitute in my values, and get the value for my arc length. So if I do that over here, we end up with L equals theta in this case is 50 degrees. R is 3 centimeters. So we would substitute 50 divided by 360 degrees, okay, multiplied by 2 times pi times the radius in this case is 3 centimeters, and we would simply just work that out. We can work it out manually, or we can work it out by hand, or we can simply just substitute those values into the calculator. I would much prefer using a calculator in this case, so I'm going to use a calculator and I'm going to figure that out. Alright, so we've got, let's say, 50 over 360 multiplied. Now 2 times pi times 3, that gives me a value of approximately 18.85. And if we multiply that whole thing together, we get 2.62 centimeters approximately. So now we know that length L over here of a circle, or that has a radius 3 centimeters, of a sector that is 50 degrees is actually 2.62. So it really is as simple as that. I mean, obtaining this formula can be a little bit tricky. Understanding how we get the formula may not always be easy, but using the formula is very straightforward. So as long as you understand what all of the values or what all of the variables within the formula represent, then it's not really too difficult to figure out arc length. And that's it, arc length.